Welcome to Inquisitive Kids. In this video, we will be simplifying this multivariable radical expression. For our problem, we have xy squared times the square root of 12 times x to the fourth times y to the fifth minus the square root of 3 times x to the sixth times y to the ninth. When we're solving expressions with radicals like this, it is important to first establish the domain constraints. If we want the square roots to give us real numbers, the expressions under each radical must be non-negative. Because we have a positive number here, and we have an even power for the x, these two will always be non-negative. And same for the bottom expression here. Because in both expressions, the y's have an odd power, y itself must be non-negative, which means it's greater or equal to 0. Now we're going to simplify each term separately, which means one radical and then the second radical. We can use the identity. The square root of k squared is equal to the absolute value of k, no matter what k itself is. This identity is always going to give us a non-negative result. Let's do the first term over here. We have xy squared times the square root of 4 times 3 times x squared squared times y squared squared times y. We are writing this out in this way to show all of the perfect squares under the radical. Now let's bring out what we can factor outside. From the inside, the 4 is equal to 2 squared, so we can bring that out. This x squared can be brought out, and y squared can be brought out. We are left with 3y under the radical. Let's simplify, and we get the first term becomes 2x cubed y to the fourth times the square root of 3y. Right now, we don't see any absolute value signs because we simply don't need them. We only have, over here we have some x squares and y squares, but because they have an even power, the roots are always automatically non-negative. So that was term 1. Now let's do term 2. We're going to do the same for the second term. We have 3 times x cubed squared times y to the fourth squared times y. We can bring out the x cubed, the y to the fourth power. This times the square root of 3y. Are we missing anything right now? Here for the y fourth, we have an even power, which makes it non-negative automatically. But we have to remember to add an absolute value sign around the x cubed, because 3 is an odd number, and x can be negative. So now we have term 1 and term 2 both simplified. Many times when we're simplifying an expression, we have to think about multiple different cases. Let's think about all the possible different cases here. We already know that y is greater or equal to 0. That's a must. X can be variable. If x is greater or equal to 0, it will lead us to one case. And if x is negative, it will lead us to another case. So let's analyze these two cases one by one. If x is non-negative, then x cubed is also non-negative, meaning x cubed is equal to the absolute value of itself. Therefore, our original expression becomes, let's write out our original expression using what we've simplified. The first term becomes 2x cubed y to the fourth times the square root of 3y. Minus our second term, which is x cubed in absolute value signs times y to the fourth times the square root of 3y. This is what we're going to be solving for from now on. In the first scenario, x cubed can just replace the absolute value sign of x cubed. So our expression becomes 2x cubed y to the fourth times the square root of 3y minus x cubed y to the fourth times the square root of 3y. This gives us x cubed y to the fourth times the square root of 3y. Now let's look at our second scenario. What would happen if x is negative? Well, then x cubed would be negative. So x cubed would be the negative of its absolute value. Now let's rewrite our original expression. We have 2x cubed, y to the fourth, times the square root of 3y, minus our second term. Our second term becomes negative x cubed, y to the fourth, times the square root of 3y. Double negatives means a positive, so we end up adding these two portions to get 3x cubed, y to the fourth, times the square root of 3y. So what would our full answer be? You would have to write out the fully simplified expression as a piecewise definition, because you have two cases. The value is different depending on if x is non-negative or negative. I hope you learned something from this video, and I'll see you in the next one.